Let me introduce to you two of the more special addresses. The special address is. It has other uses. The first one is 0.0.0.0. You have to remember. This is 40s. This address is not available. Not only 4 zeros are not available. From 0.0.0.0 to 0.0.0.255. You can't configure. Because it has other functions. At the routing level. It represents all addresses in the whole network. Can also be understood as any address. For example. In the future. You are going to access the internet. If you are going to visit various websites in the future. Then every URL you visit. The destinations are actually all different. Any business we visit. It's actually an internet business. It's the operator's business. As long as you are online. In fact. It is the operator's network. Then you just need to hand the traffic to it. It's just to help us forward. That is. You don't need to care where exactly you're visiting. As soon as you receive a data. Now use the public network to directly forward traffic to them. So now for all this traffic. We can use 4 zeros to represent. That is to say. We use 4 zeros to replace all addresses on the entire network. It is also called a default route. Second. It has another function. It also represents an address called unspecified. I'll just tell you this. Because we can't get in touch now. In the future you will be in the stage of NP. Learn a protocol. DHCP. We now turn on the equipment. Configuring IP addresses on the internet. For example. Now for my network card. I'm on wireless now. Everyone can see. I now want to surf the internet on this device. So you need an address. Then I am not manually configuring this address by myself. Is obtained automatically. In fact. The device is now running a protocol. DHCP. I do dynamic host configuration. For us. There is a DHCP server in our company. Come and configure the IP address for me. Then, during the entire configuration interaction process. When the device runs this protocol with a server. I want it to give me the address. I have to send a package to tell it first. Communication of what we call data. In fact. The point is that the data comes and goes. I want to request some business. Request some parameters. I can send it in the form of a message. Like communicating with people. Device-to-device communication can only send messages. Then when I request the address. Need to package. Data is encapsulated. For data communication. The parameters of each layer must be encapsulated. Even if you don't know. Also fill in a don't know. This field cannot be left blank. For the link. Packets are actually bit streams. It's actually what we call an electrical signal. High and low frequency is the electrical signal transmitted. If fiber is used in the future. It transmits light signals. The data transmitted by the refraction of light inside. After being compiled by the network card. It becomes 0101. When you learn NP in the future. We'll learn something. Port mirroring. When you are in the project. When actually capturing packets. You can use port mirroring. Get the real message. For example. Now this is a device. There are multiple interfaces on the device. For the interface. It always transmits electrical signals to the outside world. Then we can use another port. To enable port mirroring. You can capture the data that is actually sent so far. In the future. We are in the process of experimental configuration. I can show you. For running such a protocol. The first time you request an address from the outside world. Package address. Since you don't have an IP configured now, so you don't know what IP you are, you'll go with 4 zeros. Okay. This is the first special address. 4 zeros although belong to Class A address, but cannot configure. This is rather special. The second special one is 127.0.0.0. It refers to the entire network segment of 127 has been extended to 127.255.255.255. It's called a loopback address. We all know 127 is for testing. For example, test the network card is not bad, or the test network is not working. If you think there is something wrong with the device right now, there may be a problem with the internet. If you want to test now, everyone will choose to open CMD to ping Google. Won't open CMD to ping a 127. This means that we routinely test network connectivity. In fact, there are many reasons for the failure of the real network card. Why we ping Google? Just want to see if Google will give me back the package now. I want to see if I can access the internet now. That's for 127. It is used to test the TCP/IP protocol station inside the device. I believe that everyone must not understand. Let's go back to the picture we just made. You can see an internet here. Write a TCP/IPv4 behind. This is a protocol station that has been integrated on the device now. I told you in the last class. The network communication model we are actually using now is a model like TCP/IP. Why we talk about OSI? Because it is more clearly divided into layers. Actually, although it is clearly divided into levels. However, due to the inexperience of this organization, not many protocols have been developed. An organizational framework that supports it. And for TCP/IP, it actually has a longer history. Developed earlier. And for every layer of internet communication, it has developed a corresponding agreement for. So, that's why we use TCP/IP now. What we see now is this TCP/IPv4. This is the device itself that comes with the Windows system later, or called an integrated protocol. This protocol does not require you to manually install. But in the early days of the internet there were a lot of protocols. For example, Apple Talk, IPX and more. If you want to install such a protocol at that time, after the installation is complete, you need to test whether the installation is successful. Ping 127.0.0.1. If the ping is successful, it means the test is complete. Because only TCP/IPv4 can recognize such an address. If we fully use TCP/IPv6 in the future, that is, v6 doesn't know the address of v4 at all. Device is not recognized. If you install an IPX protocol, overall its address will be longer. Will be longer than an IPv4 address. Although it is compiled, it is also 0101. But their final representation, not dotted decimal, not 4 groups. If you install the IPX protocol, then you go to ping this address. Even if you call up the CMD command line, you use this ping. First of all, it doesn't know what ping is. Second, you ping an address like this. Definitely can't ping. Because this address does not conform to the protocol specification at all. It cannot be read.